guys, we are going to do a science experiment. Make sure you have your notebooks out, pencils ready. I want to see your notebooks open, pencils ready. We're going to do an experiment today with rubber bands. And we're going to explore the same learning target we did the other experiment, which is right here. So I need everybody to eyes over here to read this with me. Eyes over here, guys. Let's read this together. Here we go. I can explain how the amount of potential and kinetic energy are related to each other. And yesterday, we found out that the potential energy is related to kinetic in that the more potential energy, the more kinetic energy. Okay, guys, masks on, pay attention.
I have my mask on.
Paper and pencils out. I want you to write this chart.
Right. I just wrote that.
You already did. Well, you're on a good start. So you're going to write this chart. It looks kind of similar to the chart that we did yesterday. Michaela, masked.
Wait, but it's different.
It's different.
Because it says like feet.
Travel, distance traveled in feet. Stretch in inches. Okay? So while you're writing that down, Mr. Bazan and I are going to show you what it looks like.
So for the students that are doing this from home, you can either draw this in your notebooks, okay? Or maybe your teacher provided this chart already for you. Our students are doing it here, okay? It only takes a moment to do this in your notebooks, but if your teacher provided it for you, then you don't have to do it, okay? This is just getting ready for the experiment that we're about to do.
So for this experiment, we will need a ruler, and we will need a rubber band. Now, would it be a very good idea for me to point this rubber band at someone?
No.
Not a good idea. You will hit them, and you can really hurt somebody in the eye. So it's very serious.
And that
So,
hurts a lot.
yeah, so we're doing science. We're not playing around, so be very careful when you do this. What we're going to do is we'll split into groups, and we'll be on one side of the room. And we're going to shoot our rubber bands onto the other side of the room. But we're not just going to shoot them any old way. What we're going to do is we're going to measure the stretch. So I need your eyes up here. You're going to need to see this so you can know how to do it. Measure the stretch. So do you see how right there, I've measured this stretch at 5 inches. There it is at 7 inches. And now I've measured it, all the way to 10 inches. Now, we're going to find out what happens when you let go of that rubber band at those different distances, okay? So you'll need someone who's going to shoot the rubber band, and they're measuring the stretch. And then you'll need someone else. Watch, here I go. I'm going to shoot it. Boop. Oh, I got it in the trash can. 10 points. So then somebody else is going to measure the distance that it traveled. Now, what we're going to do is we're going to measure approximate distance. Okay, so your foot is approximately 12 inches long. So a foot. Thank you.
Yeah, or they could possibly use the tiles.
You could use the tiles. Yeah, maybe we'll count the tiles. My foot's about the size of a tile, but some of yours is not.
So for those of you at home, boys and girls,
You can use your feet.
you can use your feet, or if you are in a place that has tiles, square tiles, you can count the tiles, okay? So we just separated the classroom into 5 groups, and now we are going to be working in groups. If you are at home by yourself, then you will do it on your own. If you're with a group of students, then you will be in a group, okay? So right now, I am with group 1. So you see the ruler here, right? You're gonna put the rubber band and you're gonna stretch it either to 5 or to 7 or to 10 inches, okay? And then you're gonna shoot it. And you're gonna count either how many tiles or with your feet, how far did the rubber band go. This is Angel right here. He has the rubber band at 7 inches and now he's gonna shoot. Go. And so now someone is going to count how far did the rubber band go. 17. And so you will repeat this process for all three tries, okay? So the same process, just you'll stretch the rubber band just a little bit or a little bit more and a little bit more. So the next thing that we need you to do for those students that are doing this lesson at home is to graph your data. So you collected your data on the table. Now we want you to graph it. So look at what Mr. King has over here. So this line would be stretch in inches, and you would have the 5 inches, 7 inches, and 10 inches. And then over here, what is the distance that it traveled, okay? So we need to graph it to be able to see the data better. So you write your data there. If you are in a group, then you guys do it together. If you are by yourself, then you have your own graph. So you graph it, okay? You put the points where they go, and then you're gonna connect the dots. You can see over here, this is data from one of the groups, right? At 5 feet, it went like at 5 inches, it went like 5 feet. Then 7 inches, it went to something like almost 15 feet. And at 10 inches, it went all the way to like 28 feet. And so you can see the relationship between the stretch and the graph in our classroom looks a little bit different because we plotted all the groups, okay? You see that we have group 1, 2, 3, 4, and 5. Now you will see that there is the group 4, the one that is green, it doesn't follow the same pattern as the other ones. What do you think might have happened that that group did not have the same pattern as the other ones? What do you think might have happened? Take a moment and discuss that. What might have happened? Well, I will tell you what happened. Their rubber band, there was a desk on the way, and it hit the desk a couple of times. So it didn't go as far as it could have gone, okay? So that's the data they have, and they redid it after, okay? But the data that they provided was that one when the desk was on the way. So what I want you to do next is, I want you to be able to explain a relationship between the stretch in inches and the distance traveled. So what relationship do you see there? So what do you notice? What relationship do you see between the stretch in inches and the distance traveled? Okay, now it's time to share. Well, knowing how smart you guys are, I'm sure that it went something like this. The further the rubber band is stretched, the further the distance that it traveled, okay? Or maybe the more the rubber band was stretched, the greater distance that it traveled, something like that, okay? That is the relationship. So the more that the rubber band is stretched, the farther it traveled. Now, I have something else for you to do. I need you to label kinetic and potential, okay? So, what side of this graph will be potential and which one will be kinetic? So, is this right here, is that potential or is that kinetic? And is this potential or kinetic? So think about, is the stretching of the rubber band kinetic or potential energy? And is the distance travel potential or kinetic energy? So do that right now. So the rubber band was not moving, right? When it was being stretched, so that's potential energy. So this right here is the potential energy. And when it was traveling, that was moving, so that would be kinetic energy. And now I want you to make a generalization, okay? Something that always works. So it could be a rubber band, it could be a ball, it could be an arrow, it could be something like that. So those situations change. but I want you to make a scientific generalization, okay? So if we go back to our learning target, it says, I can explain how the amount of potential and kinetic energy are related to each other. So now, instead of talking about the rubber band and how far it traveled, I want you to make, looking at the graph, okay, and looking at your data, make a generalization related to potential energy, the relationship between the potential energy and the kinetic energy. So time to write. So what do you guys write? What was that generalization? Now time to share with the rest of the students. So it should be something like this. The more potential energy, the more kinetic energy. Or the more potential energy that an object has, the more kinetic energy that it will also have once the potential is converted to kinetic. Okay? So the more potential energy, the more kinetic energy. And that is a generalization because it always works. Okay? It's a generalization. It doesn't matter what you're trying, what situation you have, the more kinetic energy that an object has, or is it the other way around? Yes, the more potential energy that an object has, the more kinetic energy that it will also have, okay? That's a generalization. So thank you, boys and girls. I hope that you had a terrific time doing this rubber band experiment, and I hope that you learned many things about kinetic and potential energy. And remember, look for science. It is everywhere. So I will see you next time. Bye-bye. Have a great day.